without him.
Okay, okay, yeah, can you hear me?
Yes, I can hear you.
All right. Should I start, or do I have to wait for anyone?
I'll make an announcement on the Discord urging everyone to join.
Okay, so we're gonna give another 5 minutes before we start. Okay.
Yes, I think 5 minutes is enough.
Okay, okay. Okay, I think we should start.
Yes, we can start. Okay, I have begun recording. We can start now.
All right, hello everyone. Good to see you here. My name is Tin, and happy to be here and talk about the Polkadot. This is the first time that I joined the Mandala Bootcamp, and I also like from OpenGuild team. I think that you already familiar with Ipo. He also the team member of mine. Um, okay, so I think that we should get started, and it would be like very awesome to have like, all the people here like, open your camera, because like we live streaming it on YouTube on X, so would be great like to have you here, and also like I feel more inclusive to see like other people like joining me. Um, okay, so I think that we should start and move to the main content. Let me share my screen. So just 1 minute to talk a bit about OpenGuild. So I'm from OpenGuild, and I think you guys are already like, familiar with the OpenGuild. We collaborate with Mandala to deliver this bootcamp to help the builders who are interested in Polkadot, also like who already in Polkadot to learn more about the tech stack and also learn more about us. So OpenGuild is the community for Web3 builders and who love to contribute to open source project, learn and connect enthusiasts together with a focus on expanding the Polkadot ecosystem. And we have a lot of activities, including this one. So if you are interested in OpenGuild or also like interested in Polkadot in general, feel free to join OpenGuild, and then we're gonna have a lot of resources to incubate you guys. Yeah. So okay, so that's enough for OpenGuild. Now we're gonna move to the technical part. So I'm not sure like what have you guys learned last week, but like I think like today we're gonna like skim through the was it like the components of Pallet, the adding custom logic to the runtime, and also like common runtime modules, runtime API and RPC. Those are in the bootcamp guidebook. I already like, have like, this section right here. So we're gonna like, cover most of the part in this Substrate sidebar. So all the section are going to be covered in today's sections, but just on the high level concept. If you like have any questions, feel free to leave your like message in the chat box. So and I'm gonna take a look at that. And hope that all you guys like see my screen clearly. Okay, now we gonna get started. So adding a custom logic to a runtime. I think that you already like familiar with like a few first sections of the bootcamp to learn about like Polkadot SDK, and also like how to run a custom blockchain on your local. And with like the tool called like PubCY. And I think people also like use that tool last week to demo like how to launch a parachain with like just a few commands. And if you're like not familiar with that, please revisit that video so like you have like a full view of like what are we like learning. Okay, so for the custom logic, now you already have a blockchain running, and the idea is to add a custom logic, a business logic to your runtime. And what is a runtime? So in a blockchain, we're gonna have like different components of the blockchain. First, it's gonna be the runtime, the peer-to-peer network, which like contain like a lot of nodes, and also like a database layer. And as you can see here in the diagram, we have like the runtime, P2P network, and database layer. Database layer is the lowest level of the tech stack. And the database layer is basically a database that you already familiar in Web2, like PostgreSQL or any like RockDB. But here is lower level. And this database layer store all the data of the blockchain, especially the distributed ledger data. And sit on top of the database layer is going to be the P2P network. The P2P network, it basically contains a lot of nodes, and this node is handshaking with each other to like construct a whole decentralized network. And they share all the data stored in the database layer. The idea of the blockchain is like to have one chain of blocks. So you hear like we have a lot of blocks, right? To have one chain of blocks share across like all the nodes. So in that way, like when one of the nodes is then like already like down, you're gonna have like the data backup, and also like can recover from all the node. And this node and this data can also like verify by the node itself. And the idea of the runtime is also like the thing that we're gonna cover today. It's like the core programming logic of the blockchain. So when you interact with the blockchain, you might see like there's a lot of functionality like asset transfer, NFTs, governance, like voting on like any proposal. If you're familiar with Polkadot, we have like, a thing called like OpenGuild that you can like, visit Polkadot Assembly, a platform that like can help you to vote on the proposal to participate to the governance, the overall governance of the Polkadot ecosystem. And those are also like programmed on the runtime level. What else? Like for example, like stacking. I already let's see like some people already participated to the Mandela Bootcamp challenge, and in the Mandela Bootcamp challenge, you're gonna see like stacking system as well. So these are also like, just on the runtime level. So okay, so to wrap up, simply speaking, runtime is basically content or the logic that you want your baby blockchain to act on, yeah, to have that functionality. And Polkadot SDK allow you to do that. It's not, and to be honest, like it's not easy to customize your runtime using like Polkadot SDK compared to other stack. For example, you have like OP stack or like zkSync error, and those stack, to be honest, like it's really hard to customize the runtime. You can use like OP stack to launch an L2 rollup and a layer 2 rollup on Ethereum easily, with just a few commands. But to be honest, like all the L2 basically look the same, and it's just a general purpose L2, and they just have one single sequencer that participate to like make the L2 running. However, like if you want your L2, your layer 2 rollup to have like some like custom logic, it's not easy to do that in the other side compared to the Polkadot SDK. And with this runtime in Polkadot SDK, you also have the ability to forkless and seamless operate. What does that mean is, let's say like I have the runtime at version 1.0. Later on, it's already in production for 2 years. I want to add a new functionality to my blockchain. And to do that, I have to do the upgrade. And you cannot like simply just push the code to GitHub and it seems similar to the web server. But in this way, in blockchain, you have to do an upgrade to maintain like all the previous state. But you can also like continue like the change of block with a new state of the new runtime version. So Polkadot SDK allows you to do that without like any fork. For example, in order change, if you want to do an upgrade, you have to fork the change. Let's say you also have like Ethereum classics, as I remember, and those are basically like forking in the Ethereum. Whenever you do a major upgrade, you have to do soft fork or like hard fork. And I already mentioned about POPs UI, so I don't think it's needed to cover here. Substrate framework, running local. Okay, I think like all these are covered. Now we go to the adding the custom logic runtime, and I think you're already like familiar like what is the runtime, right? And to custom the runtime logic, we're gonna like visit the concept called like Pallet. Pallet is basically a module running like adding to the runtime, configure to the runtime, and each like module is like a Lego block. So imagine like a Lego block that has their own like functionality. If you want your blockchain to have that functionality, you're gonna add that Lego block. For example, like if you want like your blockchain to have like asset management functionality, you have to add like Pallet asset to your runtime. Or if you want like to have like governance in your blockchain, you're gonna have to add Pallet governance. I remember Pallet governance to your runtime as well. And to discover all the module, you can go to frame Pallet, Substrate. Yeah, and when you click on it, you can see like in any of the Substrate runtime, it's already like cover some. It's already like have some foundational palette or like here is a system palette, and you also like have some set of palette on top of the system palette is like support libraries. You also have the executive palette that orchestrate or call into the palette from the runtime. And on top of the executive palette, it's going to be like the user defined palette, or I can say like the palette that you reprogram on your own. We usually call that like application palette. Yeah. Now we go back to the component of the palette. I hope that you already understand what is the palette. If you like, if it's not clear to you, feel free to ask a question. So the palette contain a few different components. So in the palette, you have a storage, which gonna be like one of the key things in the palette. Whenever you program your own palette, you have to like define a new storage. It's optional, but like most of the time you're gonna have to use the storage. So it's quite important in palette programming. So what is the storage? It's basically like when you want to store the data. And we already did talk about the database layer. On top of the database layer is going to be the runtime. And if you like add a new palette, you want to define new logic. How do you write to the database layer? You have to define new storage, and this storage is going to expose some storage API, allow you to write to the storage to the database layer underlying of the runtime. So there's a few different data structure of the storage. You have a body vector, storage nmap, storage value, and storage double map. And I'm gonna visit the storage as well. It's gonna be the frame support storage. Yeah, so here, like when you go to the Polkadot SDK doc, you're gonna find the storage, that structure. In the storage documentation, you're gonna find like the storage double map, storage list, storage map, storage nmap. There's a lot of the structure here, but I only like cover like some of the basic structure that most of the time you're gonna need that. The first one is gonna be the storage value. Here, the storage value is basically of scalar value. That's mean like a single variable, something like that. For example, like the integer or the boolean, a string is basically just a storage value, a scalar value. For the storage value, you're gonna have like some API, as I already mentioned about the storage API. You're gonna have like some API like get or set. Yeah, quite similar to like Web 2 programming that you can like set to the storage, write to the storage, or read from the storage. Basic, right? You also like have some other method as well, like mutate exist or mutate. So what does the mutate exist means? So the mutate exist is gonna return the optional value of t, the generic type, and you can handle the check of the value inside the mutate exist. This one is received the lambda in Rust, and it's not like return the value directly. I'm gonna give you an example how you can use that. I'm gonna open the Visual Studio Code. Okay, so here I have the palette unique. This palette unique is basically the palette NFT provide the non-fungible token management functionality to the runtime. And in this palette unique, you're gonna have it's usually try mutate exist. What does this try mutate exist do? Is basically like read the collection by the collection ID. Yeah, read the collection by the collection ID, and then it return the maybe details. That's mean like it can be there's a collection or not. And in here you can basically like check if there's a collections, then we take it, or we're gonna throw an error like unknown collections. And that's how that the try mutate exist work. With get, you can find with the get, like it's simpler. So get, like if you define the value query as like default value, that's mean like if you get the data, if there's no the data exists, then it just return the default value. Otherwise, it's gonna return the optional value. Here, there's a few called like query. This query type you can like go to the query. This is a tip that like whenever you work with like Substrate, it's a good idea to just clone the Polkadot SDK on your local, and then open the Polkadot SDK side by side. So like you can like search for the informations directly on the Polkadot SDK, because basically like, everything in Substrate is is in the Polkadot SDK. So there's a like different type of the query type. For example, the query. Wait, not this one. Yeah, sorry about that. Like the query type is basically the type of the storage value, as I remember correctly. Okay, I think like we already get the idea of storage value, because there's like more storage type here. So we don't dive deep into to that too much. Now I'm gonna go to the storage map. And in programming, like if you already have the Scala value, the map gonna be like the second most popular data structure. So in the storage map, you also have some set of storage API, like content key, that there's the value exists in storage. Or the get, like you load the value associated with a given key from the map. Or the set, like store or remove the value to be associated with the key, so that the get return the query. Insert, that you provide the key and also the value, is gonna override the storage map entry with the new value that you add into the insert method. Or you also have the remove store API here that provide the key, and then like in that way, like you can remove that store entry completely by the key. Yeah, quite basic. Now we're gonna move to another advanced storage structure, like the store nmap. What the store nmap does? So the store nmap is basically receive the key generator. This key generator that like it's mainly it can have n like n number of the key, not just only one. For the storage map, you can see like there's only like one key, but in the storage nmap, you're gonna have like a key generator that accept like tuple of keys, and it generate the key from those. That's how amazing the storage nmap is. Now we're gonna go to the code again. Storage nmap. Maybe storage map first. So in the storage map, you can find here you have a hashers. We're not worried about that right for now. But the hasher basically it's just like the hashing algorithm that we're gonna use to hash the key. Because some blockchain is public, right? And then you also like want like your the data in some way is gonna be less secure enough. So it's required hasher. And you can also like basically like customize the hasher on your own. On the other hand, the hasher also like make traversing like the data, like carrying the data like faster. But that one we don't handle that. But that's how the Substrate does. That is depend on the hasher to construct like the underlying data structure to store the state data under the hood. Now we only like care about the key and also the value. Here the query key. So the query key, we're gonna have the option value or the value query. And I did mention that in the storage value, but it's not very clear. So when you set the value, when you set the query key as option value, option query, when you get the value by the key, but if with no value exists, then what is return is return the option. But for the value query, it's going to use it like the default value. So when you get the key with no value exists, it's going to return the T instead of the options. And that's how the value query works. By default, it's going to be set to the default value, as I remember. If the type doesn't have any default value, it's going to set to the option query. And as you can see here in the storage map, it's going to accept the key and the type of the value. Only one key. Now we go to the storage nmap, and in the storage nmap, Yeah, in the storage map, as you can see, that it's received the tuple of keys. Here you have like 3 different keys combining together, um, to construct a single key of the storage map entry. It's gonna accept the asset ID, account ID, and also the account ID. Reason the use case that we need the storage map indicates that, like, we, for example, the approval of the storage of the pallet asset. In the approval, we're gonna to have like the association between the asset, who own the asset, and who gonna be delegated by the owner of the asset, and those entity combining together become like one single key of the storage map, and it cannot be easily done with the storage map, because if you do the storage map, you have like to do like one storage map, store another storage map, and store another storage map, because you have like 3 different entity here. That is when like you need to use the storage map. There's another storage type that I think also useful is storage double map. It's basically just similar to storage map, but here it's just only accept 2 key. Now we go to the storage double map. And in the storage double map, as you can see, it's only accepted key 1 and key 2. You cannot like define key 3 here. For the storage double map, like the storage API is easier to use compared to storage map. So if you only need 2 key for your entry, maybe like refer to using the storage double map instead of storage map. Okay, so now we go back to the document. So that is about the storage. How about the event? The event is basically the notification module of the pallet. So whenever you want, whenever there's a new actions coming from the pallet, you want to notify the blockchain, or maybe notify the user using the pallet about that event, about that call, and that is where you use the event. But before we look at the code of the event, we're gonna look about we will look at the dispatchable functions. Most of the time, we're gonna call that dispatchable. So the dispatchable function is gonna be the main entry of all your logic. The pallet, to customize the programming logic of the pallet, you have to define a set of dispatchable function. It's similar to the function in like traditional programming. This function like contain like some set of like Rust programming code to define the logic that you want to mutate the blockchain, or maybe like read from the blockchain. And as we already like have the code here, we're gonna look at the asset. So we go to the asset palette, and in the asset palette, you can find all dispatchable function in the palette core. In the palette core, like you have, for example, like this palette asset, it have the method to create, issue a new class of fungible asset. This method basically like create a new asset, create a new token. So this method is inside the palette core. So every dispatchable function must be contained inside the palette core, and this palette core is the trade implementation, and it's derived from the palette core derivative macro. So this dispatchable function is have like the parameters, and you also like have like other method like start destroy, or like destroy the account. This method basically like destroy the account on the blockchain, destroy the account that having containing the token. But you also have destroy approval. We just look at the approval storage item before, and let's say if you want to remove the approval from like any delegate, you can like call this method to destroy the approval. Or you also have the mint. So now that you have like the token on the blockchain, right? What happens if you want to mint the token for someone? So you're gonna like call this mint method, it accept the origin, the ID, and the beneficiary. The beneficiary is basically like the one who gonna receive, that means it's token. The another part is also the origin. Most of the time, the origin is gonna be the account on the blockchain, but in fact, like, it's not only the account, but like it can be more than that. For example, like if you have like a group of on-chain identities, like a DAO on your blockchain, and you want that DAO to call the method, then like that DAO can become the origin. Or you also like have the pallet pseudo. So the pallet pseudo is basically like allow the super users to like execute any method, execute any dispatchable function from all the pallet. So this pallet pseudo, when you look at the method like pseudo, so this pallet pseudo accept the origin, but this origin is gonna call the method like and pseudo. That means like the origin must be the super user. So it's not only about the account, but can be more than that. Depend on like the constraint that you apply to the origin. So like here we check like if the origin is the pseudo, then we allow them to call this method. And as you can see right here, after calling the pseudo, it's gonna deposit the event suited. Yeah, basically a super user did something, and it's gonna like emit this event. And we're gonna take a look at the suited as well. So the suited is the pseudo call just took place. So all the event are put inside this enum, and this enum also like derived from the macro like pallet event. And you also like need this macro right here to have the method like deposit event. This method you can like customize yourself. You can maybe like call it like deposit a beautiful event. Pseudo. Yeah, and then like here you're gonna call it deposit beautiful event instead. So like it's depend on like the name of the method you define there. The next component is gonna be the error. So what happened like if you want to emit the error, token error from the pallet, then you're gonna have that error enum. So when you go to the error is basically also the enum similar to the event, but using like derived from different macro, call it pallet error instead of pallet event. And each variant in the enum is basically like an error, similar to like Rust programming. So you're gonna define some set of error here, and when you use that, you can call error, and then like towing error, similar to like towing an error in Rust. There are other advanced concept there as well, like transaction extension. These are basically the same, just in a different version. Transaction extension. So let's say like if you want to wrap your transactions, when you submit a transaction to the blockchain, you want a special transaction submitted. So in that way, you can like wrap the transaction submitted to your blockchain with like a transaction extension. For example, like you can visit like the transaction payment. In the transaction payment, you're gonna find the extension. Yeah, this transaction extension is basically have like some method that you have to define like the validate, repair, or post dispatch detail. The transaction payment method, transaction payment pallet is basically calculate the weight tag, calculate the computation tag from like the actions inside the transactions, and it's calculate the weight and then charge the user from for like the computation that they requested. Yeah, there's another component called a hook. So the hook is similar. If you like code in React already, you're gonna familiar with the hook. For example, like use effect or like use state or like, yeah. So the hook is basically like you put the hook there. Whenever there's some kind of event happen, then the hook is gonna be called. For example, you're gonna have the hook called a block on initialize and on finalize. So when on initialize happen when let me take a look at the hook. Yeah, so we're gonna have like all initialize and also like all finalize. So all initialize hooks gonna be triggered when the code change is detected. No, all initialize hook gonna be triggered at the very beginning of the block body. I think the document here is a bit wrong, but here it must be the all initialize, and the above would be like all runtime upgrade. So the all initialize hook gonna trigger at the very beginning of the block body. That's mean like when the system trying to build the block in the backend before submitting to the change. At the very beginning of the block constructions, this hook gonna be called. And if you define that in the palette, for example, you want like whenever the new block constructed, you're gonna distribute all the fund to like some set of account. Then you can define that on the on initialize hook. You also have all the hook called like all finalize. All finalize is basically similar to the all initialize, but like in different way. That is happen after the block constructions. After the block already repaired and then ready to submit it to the change, then it's gonna be called the all finalize. Maybe you can call the hook all finalize to clear like some set of like data that you don't want to have on your change. No, I think the diagram is already correct. This diagram is copied directly from the official Polkadot SDK documentation. So I'm quite sure this is already correct, I guess. Maybe like the description here is a bit wrong, but yeah, like you guys should double check. But like I think like the idea like is quite similar. But the tip here would be like don't try to use the hook all the time, because like hook is have like the limited time span to execute the logic. As I remember, like the I think I also have the diagram here. So hook common must be extension. Yeah. So here like you have here's like the 6 seconds block construction time. So when you construct a block, you on Polkadot, you have like 6 seconds. So in this like 6 seconds, you're gonna have like the first 2 seconds to handle like all the reparations, all the hook inside the available time span, and the buffer are gonna be storing the data of the transactions, like handling like all the logic of the dispatchable or something like that. And in this like available, you're gonna have the all initialize and all the finalize. So all initialize happen before the extrinsic dispatch, and all finalize happen after the extrinsic dispatch. Yeah, understand in that way it's easier to understand. Yeah, and the extrinsic gonna be executed between the all initialize and all finalize. There's also a document here that you can visit. Yeah, now we already cover the component of pallet, weights, and benchmarking. Now we go to some common runtime module. Yeah, I think this document right here is already quite clear. Maybe you guys should spend some time to read that. Some common runtimes we already cover sudo, that the pallet allow you to call any dispatchable as a super user, or you also have pallet over. So pallet over is the block production pallet that have like the block production pallet, following the mechanism of the round robin. So you want your block change to produce a new block in like a simple way. So most of the template when you initialize, it's gonna use pallet over. So the pallet over just basically allocate each validator to participate to the block production round, and then produce a new block, and then move to the next validator, and then produce new block again. So this is the most basic block production mechanisms that you can add to your block change. We already like talk about the asset management palette, allow you to like define the functionality to create a new type of asset, a new token. Yeah. You also have like Pallet collective that like create a collective, a group of account on your blockchain. For example, on Polkadot, we have the Polkadot Fellowship. So the Polkadot Fellowship is basically a collective, an on-chain collective that created to gather all the people who interested in like technical development of Polkadot protocol. You also like have the timestamp. So as a decentralized computer, we want our computer also have a timestamp, because timestamp is quite, it's like the most core component of any computer system. Because like with the timestamp, yeah, you can like do the scheduling or like see like what is the current time, and then like trigger some set of event. So you also have the Pallet timestamp here to capture the timestamp, to view the timestamp for your runtime. Yeah, there are also a few other Pallet, like Pallet EVM. This Pallet EVM is quite advanced. So this Pallet EVM is simply provide all the functionality to like execute the EVM compatible smart contract, like EVM bytecode. Yeah, to execute the EVM bytecode and change the state of your runtime. We also have like the Pallet multisig. So the Pallet multisig allow you to create a multisig, an on-chain multisig. Yeah. If you're not familiar with the multisig, so a multisig is basically like an account that have like multiple private key that can decide on like that can like approve whether the multisig gonna do this action or that actions. For the contract, the Pallet contract allow you to execute, allow the runtime to execute any like WebAssembly compatible smart contract. But in the short future, we're gonna migrate to the PVM and no longer use like WebAssembly. So the PVM, let me see. Yeah, the PVM is the virtual machine written just specifically for Polkadot, and it's based on RSC5, a very low level instruction set. But the PVM is faster, and yeah, the PVM is faster and also less secure, easier to port to like different hardware. And the Polkadot gonna migrate to that soon. So this Pallet contract is no longer only like just execute like WebAssembly compatible smart contract, but also like Polkadot VM compatible smart contract as well. You also have like Pallet identity that allow you to define the on-chain identity on Polkadot. If you go to like Polka assembly, and you're gonna see like some people here, some account here, gonna have like the identity, like this guy, like who then, yeah, this guy have the username, right? And this username is basically configured by the user, and this username is stored on chain, stored directly on the Polkadot blockchain, not just like some set of like backend server that store this handle. Yeah. And there's a few different templates that you can use as well. So let's say that if I'm gonna start my terminal, and then in the terminal, I'm gonna run pub new. Or maybe I'm gonna go to the base pair change. I think I already have that. Cd base pair change. Then I'm gonna run the pub new pallet. And what does this pub new pallet do? So you can do the pub new pallet help. And this pub new pallet, it allows you to create a new pallet, create a simple pallet, like do some advanced mode. For example, like you can define some kind of emit event, also like the origin, the currency, like adding more more configuration to the palette. Maybe like we're gonna do like storage value. So we're gonna do the storage, advanced storage, and then storage value. Maybe the storage nmap. Then create inside the template. Now I have the template created. I'm gonna go to the template. Leave errors. Yeah, as you can see, like after you running the command, you already like see storage nmap created. So you don't have like to look at the document, but the pop CY already like generated for you. Now we go back. Yeah, that's how like, you can use the pop CY command to like initialize the template and also like create a new palette so that you can start working on the next logic for your runtime. Let's see like, what I haven't covered yet. So we go back. I think that the last part for today's section is going to be about the runtime API. So the runtime API is quite simple. That is, you can like define some set of API that allow you to like allow the runtime and the host, or you can say like in the node, to communicate with each other. So you can imagine like the runtime, the runtime and the node, even though it's still in the same blockchain, but it's still like two different components. And you also like want to expose like some set of API that the node can call from the runtime, and also like set as the node can expose the API so that the runtime can call from the node. So the node, the runtime API, we're going to be allow the node to communicate with the runtime. Meanwhile, the runtime can use like the host functions to communicate with the node. Actually, it's an outer node service that another layer of the node sit like outside the node that like the runtime can communicate to it, similar to this diagram. Yeah. So the outer node services and the runtime must communicate with each other to complete many critical operations, including reading and writing data and performing state transitions. Yeah. For beginner level, like you don't have to care much about the runtime API. But like to write the runtime API is also like a simple concept. Now I think I'm gonna skim through this Mandala Bootcamp challenge a bit. So we have the challenge here that asks you to write the logic for your palette. Here like, we have like the governance, the stacking, and the system. So in the governance, you also have we already define some set of struct. Oh, I think I'm not sharing my screen. Am I? Yeah, you can in the bootcamp challenge. You can have you have the enum and also the struct, and then like your goal is to write the logic for this method. For example, like create a new proposal using like the struct that you already provided, or you also like vote and get the proposal. So the idea is to write the logic for this method. You can also like reference from the existing logic on like pallet governance or like pallet stacking to the finish all this method. So that's the idea. And the bounty, we also have the bounty for that. So I think that there's already like a bunch of people submitted the challenge, their challenge solution. So if you like not like haven't like finished it yet, feel free to visit the repository and finish the challenge, because that's also the part of the bootcamp. And I think that that's also a wrap up today bootcamp. We already like go to the 1 hour of technical solutions, technical overview. So if you have any questions, like feel free to ask in OpenGuild Discord, in Mandala Discord, or like ask the question directly here. And you're gonna we also like have a system called like XP that if anyone asks the question, we're gonna delegate the XP to you guys after the call, and you also like receive some benefit from that. And that's all. Thank you for listening to the today bootcamp sessions. And yeah.
Okay, does anyone have any question? Okay, there's a question by Muhammad Ramadhani. How can substrates of chain workers be leveraged to integrate real-time data feeds into a parachain?
When you say like leverage to integrate real-time data, you mean like how does it work, or you mean like how to program that?
Hello, Muhammad Ramadhani. Can you answer?
Yeah, I mean like, do you mean like the implementation, the underlying implementations, or um, you mean like how to program, how to integrate your off-chain worker to your runtime? Like, are you curious about the implementations, or are you curious about like, how to integrate that? For the implementation, as I remember, the off-chain worker is basically just like a side server running along with your runtime. So when you start your runtime node, the off-chain worker also start as well. Because like if you want to like integrate the off-chain worker to your runtime, you have to add a code to start the off-chain worker on the node level. So when you start the new node, that off-chain worker also like running side by side of the node. So that means like one node gonna be associated with one off-chain worker. So if you have like 10 node, there's gonna be like 10 off-chain worker, and these off-chain worker are gonna be accessed to like one specific private database of sit like under that node, and these private database are not shared across each other. That's the difference between the off-chain worker and the node itself, because like the node gonna share the data across all the node in the network. However, the off-chain worker gonna have like their own space to store the data. So you can imagine like the off-chain worker is just another server running along with the node, and then it's not like access to the data on the blockchain. The off-chain worker cannot access the data on the runtime. So in that way, like you can like do any like heavy operations inside this off-chain worker and send it back. You can send back, but you cannot. No, as I remember, like you can read the data on the runtime, but you cannot write the data to the runtime. Yeah. I hope that that's answered your questions. I think it's a bit different from the Oracle. The off-chain worker is a bit different from the Oracle. But you can actually like use the off-chain worker to build the Oracle solution as well. But in reality, like the Oracle itself gonna have more mechanism to make it secure compared to just similar to the off-chain worker that have like the side server running along. Yeah. Are there any other questions? What kind of apps that we can make from Polkadot CDK beside NFT? Um, I don't think that NFT is the only use case of the Polkadot SDK. The Polkadot SDK has a lot of capabilities that allows to do a lot of things. For example, I don't know if you visited that yet, but if you go to the Polkadot stacking, so this stacking applications is a nomination. Oh, I forgot to share my screen. Yeah, so if you go to like Polkadot Cloud stacking.polkadot.cloud, you can find like there's a lot of no, like you can find like this application is basically a stacking application built on top of the Pallet stacking, not just NFT. So this one is a financial application, right? And any people like can like stack your dot to earn like from the nomination pool, to earn from the validator, from like the block validator. You can participate to the nomination pool and then stack your dot and then like earn from it. So that's one application of built on top of pallet stacking inside the Polkadot CDK. What else? I think the Polkadot CDK also allow you to do like a lot of exchange. So you also like have like, for example, a Mythos. So like Mythos Foundation, Mythos, a blockchain like built on top of Polkadot, like do like gaming blockchain. It's also have NFT here that is allow you to transact, like allow people on Mythos change, to transact their gaming collections with each other, gaming skin, for example, the skin with each other. So you can say it's also NFT, but I think it's have like more use case than that. For example, like it have like governance, or also like token as well, or you also like have like hierarchy DX, another application built on top of Polkadot SDK. So this hierarchy DX is a decentralized exchange that allow you to swap the token cross-change using cross-change for across like all the blockchain inside the Polkadot ecosystem using XCMs, a cross communication language. And then like, for example, you can like swap your token from USDT to USDC on Asset Hub, or you can also like swap from USDT on Bifrost to another token on like Interlay. Yeah, like IBC on Interlay. So there's a lot of use case for that. I hope that answered your questions. Okay, I think like if there's no other questions, then that's the end of today's call. And really happy to have you here, and thanks for asking questions and participate to the call as well. And I'm Tin and really excited to be a part of this. So if you have any questions related to Polkadot, feel free to leave in the OpenGuild Discord. And thank you and have a good day.